Welcome to part 2 of our test number 3 review for pre-calc. I am going to start this session by solving a lot of equations. So this is where we solve for x, and remember our strategy is see if you can make the same base. If not, see if you can isolate and switch forms. If not, natural log of both sides. So looking at this one, log base 7 of x plus 1 equal to log base 7 of x minus 3 plus log base 7 of x minus 2. I have log base 7 of everything, so I can make the same base on both sides. But I can't just drop the log, I have to consolidate it on the right-hand side first. So log base 7 of x plus 1 is equal to log base 7. And when we add its multiplication, so x minus 3 times x minus 2. And now I can set my arguments equal. So x plus 1 is equal to, I'm going to FOIL this, x squared minus 5x plus 6. And now this is a quadratic. I need to solve it like one, so I need to move everything over to one side. So 0 subtracting x and subtracting 1 is equal to x squared minus 6x and plus 5. Now I am looking to see if it factors. So two numbers that multiply together to give me positive 5 and add together to give me negative 6. Now they both have to be negative, so negative 5 and negative 1 will do it. And I get 0 is equal to x minus 5 times x minus 1. Now I get two solutions. First one gives me x is equal to 5. Next one gives me x is equal to 1. I need to check and make sure that both of these solutions are in my domain. So here, if I look and plug in x is equal to 5, I get a positive number here, good to go. Positive number here, good to go. Positive number here, good to go. So that one is a correct solution. Now looking at the other one, x is equal to 1, positive number here, fine. Negative number here. So x is equal to 1 is not a good solution. This one is not in the domain. So moving forward, all right, solve for x where I have log base 8 of x plus 6 equal to 1 minus log base 8 of x plus 4. So there's a couple different ways to do this one. Like most of log problems, I can either turn that 1 into a log base 8 of 8 and then combine it, or I can bring the other log to the other side and then turn it over to exponential form. I did the combining it and turning that 1 into a log base 8 of 8 in class, so I'm going to do it the other way this time. So if I move the log base 8 of x plus 4 over to the other side, I have log base 8 of x plus 6 plus log base 8 of x plus 4 equal to 1. Combining log base 8 of x plus 6 times x plus 4 is equal to 1. And then since I've got it isolated on one side, I can convert now to exponential form. So 8 to the first power is equal to x plus 6 times x plus 4. Now don't set each of those equal to 8. Algebraically that doesn't work. I have to FOIL it, move everything to one side, solve it like a quadratic. So 8 is equal to x squared plus 10x plus 24. Subtracting 8 from both sides, I get 0. X squared plus 10x, woo, not 16, x squared plus 10x plus 16. And I'm thinking about things that can multiply together to give me 16, add together to give me 10, gives me 8 and 2. So 0 is equal to x plus 10, or x plus 8, and x plus 2. All right, solving, I get x is equal to negative 8 and x is equal to negative 2. Now, just because they're negative doesn't mean they're out, but I do need to check them. So if I check -8 in my functions or in my logs, I get a negative value here. Not good. So -8, not a good solution. -2, on the other hand, x plus 6 gives me positive, x plus 4 gives me positive, so x is equal to -2 is the solution. Now, if I wanted to work this the other way, turning the 1 into a log, then I have log base 8 of x plus 6 is equal to 1 is log base 8 of 8 and minus log base 8 of x plus 4. Now when I put things together, remember subtraction is division, so log base 8 of x plus 6 is equal to log base 8 of 8 over x plus 4. And then I set my arguments equal. So x plus 6 is equal to 8 over x plus 4. And then multiplying both sides by the denominator because I need to solve for x. So I end up with, on the left-hand side, x plus 6 times x plus 4 equal to 8. And if you take a look, that is right where we ended up here. So the solution from here out would be exactly the same. We just started in a different place and got there a different way, but it's still legitimate. So whichever version you like better, stick with it. Solve for x, leaving answers in exact form. All right, so strategy, same base, isolate, or logs. Now looking at this, it's already isolated for me, so I can turn this into log form. So remember, base e is the natural log. So I have the natural log of 12 is equal to -4x minus 2. So continuing my solution, I'm solving for x. So I'm going to add 2 to both sides. So I have the natural log of 12 plus 2 is equal to -4x. And notice that I put the 12 in a parenthesis, and that's really so that you know exactly what the natural log argument is. Because if I just wrote ln 12 plus 2, you wouldn't be sure if it was ln of 12 plus 2, or if it was ln of 12 plus 2, or ln of 14. So be careful on your notation, because I don't want to be unsure what you think. And a parenthesis here is good. What is also good is putting the 2 in the front, so 2 plus log base, or ln of 12. That works as well. Either way, dividing through by -4, I get the natural log of 12 plus 2, all divided by -4, is equal to x. Okay, perfectly good answer. Doesn't look pretty, but that's what x is equal to, and you can leave it there. You can also factor the negative out to the front to make it look a little nicer, but either way is fine. Solve for x, leave answers in exact form. I have 6 to the 3x plus 2 is equal to 5 to the 2x plus 3. All right, first question, can I make the same base? Well, using rules of logs, there's no way really for me to turn a 6 into a 5. So no, strike out, or strike 1. Second option, can I isolate it on one side? And I have my x in the power on both sides of the equation, and the bases are not the same, so I can't. Strike 2. So my next option is to take the natural log of both sides so that I can bring the power using rules of logs out to the front and solve for that x. So I'm going to take the natural log. I have the natural log of 6 to the 3x plus 2 is equal to the natural log of 5 to the 2x plus 3. Now the whole reason I did that is so that I can shift this power down to the front. Now notice I put a parenthesis around the power, and that's because I need to remember to distribute, so I want to make sure that I don't mess that up. So 3x plus 2 times natural log of 6 is equal to 2x plus 3 times the natural log of 5. Distributing 3x ln 6, got my x there, it's kind of the important part, 3x ln 6 plus 2 natural log of 6 is equal to 2x natural log of 5 plus 3 natural log of 5. All right, you can't solve for a variable if it's on both sides of your equation. So I'm going to reorder or regroup my stuff, and I'm moving this one over here and this one over there. So 3x ln 6 minus 2x ln 5 is equal to 3 natural log of 5 minus 2 natural log of 6. And then I'm going to factor out my x. So x, 3 natural log of 6 minus 2 natural log of 5 equal to 3 ln 5 minus 2 natural log of 6. And then putting it all together, I'm going to divide by what's being multiplied by my x. So x is equal to 3 natural log of 5 minus 2 natural log of 6 all over 3 natural log of 6 minus 2 natural log of 5. Now there's nothing that you can cancel there. I have subtraction both top and bottom, and the terms are not the same. So don't be tempted to cancel because you can't, and this is your final solution. You could put the logs together, but it is a bunch of algebraic, well, not really a bunch, but a bunch of algebraic work that doesn't actually get you a different answer. So don't worry about that. Just leave it the way it is. All right, you should also expect to have a couple of applied problems. So this first one says the number of hits a website receives every month can be modeled by P of t is equal to 4080 e to the kt, where t is the number of months the website's been operating. If the website had 10,000 hits on the third month, find the rate of k. So it has 10,000 hits. That's the amount that you have after time. So that's our P of t. Now here it's the third month, so that's an amount of time, and we can plug those things in order to find k. So 10,000 is equal to 4,080 times e to the 3, because 3 is t, so 3k power. Dividing both sides by 4,080, so I have 1,000 over 408. I just knocked off my last zeros, equal to e to the 3k. And converting it to log form so that I can solve, I have the log base e, or the natural log, of 1,000 over 408 equal to 3k. So if I divide by 3, I get what k is equal to. K is equal to the natural log of 1,000 over 408, all divided by 3. And I'm going to put this into my calculator, and I have the natural log of 1,000 divided by 408. Then I'm going to close my parenthesis, divided by 3, gives me 0.2988 for my decimal. So if I want to rewrite my function based on this, so P of t is equal to 4,080 e to the 0.2988 t power, and that's my resulting function. Now the resulting function is important because I'm going to use it to answer part B. Use this information to find the number of hits during the 10th month. Well, that's for a t is equal to 10. And I can say the P of 10 is equal to 4,080 e to the 0.2988 times 10 power. And this particular one is just calculator work. So I'm plugging this into my calculator, and 0.2988 times 10 gives me 80,971 hits. and I rounded to the nearest whole number. Watch for rounding instructions. It's appropriate to round to a whole number here because you're talking about numbers of hits. Whereas a rate, we keep a lot of decimal places.